Well, I guess we'll get started here. Hello, Rob. Thank you for joining us, and Steve. Thank you for joining us, Andrew. Roger, it's a pleasure. Haven't spoken in a while, Brad. And so we'll kind of jump into it a little bit. We'll just do a quick refresh and then get into the program in a little bit. Do you see the Verisurf website on your screen?
Yes.
Excellent. So general website, basic stuff, some of the solution suites. This is all the industrial section here. We have email support and how you download the program. It's all very intuitive, straightforward. Here's the education section. Discusses on software briefly. This is a brand new website for us, by the way, and there might be still a few bugs in it. This is the hardware we're selling directly. The ZCAT's a new offering, which measures small parts. It's just like a portable CMM, if you will. That arm, horizontal arm, comes out and goes up and down. So if it's a portable 3-axis CMM, if you need pricing, I can get that to you. And we got training. And then, as I mentioned earlier, anybody that wants to get the free software program download of Verisurf, they can just by registering here, and we'll send you the link. And as we get into later, I'll show you how you use your mouse to inspect and analyze a part. The way we handle our online video is an easy way to go through. Let's see, let me find it here. Is off the Immerse to Learn website, and Frank, you're an Immerse to Learn dealer. So essentially you go to the Immerse to Learn website, go to the product section, scroll down to inspection metrology, and you can sign up still for free there for 3 months. Still offering as a free item. We haven't shut that off yet. So during COVID, like Mastercam has, we're offering the online video training for free, which is nice. It's about 22 hours of actual video at this point. We've added reverse engineering, and we've added how to set up and program a CMM that we sell. That's the Renishaw unit. Right.
Hey, Ray,
so,
if they already have a system connected, but they haven't really gotten up to speed yet because of the COVID, but it's already connected, is this good software for them, this training, 22 hours good for them to jump on? They've had maybe a quick start. There's a client of ours that already has the software, but haven't gotten formally trained. Is this something good they could jump on and use their system they bought, which was, I think, the Spider, or the one of the very last there?
Yeah, absolutely. It's a great way to get the ground game started, get the basics in, get a rudimentary understanding of how it works, so you kind of get into the groove of it. And absolutely, I'm more than willing to jump in and help out wherever we need to get them going. I don't know if they actually purchase any 3-day training or not, but we can get into those things.
Thank you. And
So
if they don't have a system, they can just use their mouse to practice on, if you want to take this.
Yep, and that's what we're going to go through today. I'm cognizant of keeping an eyeball on the time clock here. So this is how you use your imagination. Here's the part that we're going to be measuring today. It's our standard tutor part. It's in all our videos, all the training, everything is designed and built around this part. And there's an arm that we sell a lot of. And that arm is tougher than nails. It lasts forever. They just keep on ticking like a Timex clock. It's amazing how well they work and how long they last. Eventually, once they get trained up, they can design and build their own parts and CAD models like this, so they could add the dimensional nomenclature to it if they'd like. Depends how advanced they want to go. Size is no object when it comes to our software. The software doesn't care what size the part is or what the problems are. It's really the hardware device that you're going to use to collect the data and then analyze it and apply it. And I look back at these old pictures of how these guys did it back then. I'm just amazed. I'm just super amazed how they accomplished what they did with all the rudimentary tools that they had for inspection and measurement and alignment. It's just phenomenal. Here's a little project I did for UCI. This was the car that they built for the challenge at SpaceX for the Hyperloop. I went in and helped them out a little bit, getting the wheels aligned, the brake pads aligned. So the applications are wide and varied. This is a particular application. Same software, same program, same everything. On this particular one, there's a device back here in the corner. It's a laser tracker. It's a surveying instrument with a laser in it. And he's holding a little reflector prism here. And they asked us to come in before they bought our product, and we measured the raw casting after it had cooled off to make sure there's enough material there before they started machining on that thing, because it's a 3-week machining process on that part. They didn't want to get 3/4 of the way through it and find out they had a void or a low spot. So we validated that the casting was good. And then they went ahead and purchased from us. Customer, Frank, this is your customer out in Hawaii. They just put this out recently. They bought the arm from us and they put it up on this car and measured the top of the car with it, got the dimensional data off of it, and then they started manufacturing these roof racks as a student project. So Tran might be interested in that up at Cal Poly, type of projects you guys like to do up there hands-on.
That's cool.
And additionally, they can do it at their home. So if, I don't know if you guys have an arm up there or not, but once you scan something in, you could build it. That is neat. Now they're selling them over there in Hawaii. That's Wailea High School and Robotics Academy. They're doing great things up there.
Did you go over there, Ray?
Pardon me?
Did you go over there?
No, I did not. Everything has been internet, email.
Okay. Bummer.
Yeah. Those guys, they've been winning the robotics championships around the world. I mean, they've got a heads-up program and they're into it. A snapshot of some of our industrial customers. So as they move through the high school, community college, university programs, all these people are hiring. And this is about 6 years old, that list. Here's a project I did about 5 years ago, measuring arm with a long probe on it, going up inside the port and mapping the inside of that port. Once they assemble the engine, they run it and they find out which cylinder is making the most horsepower off of the dyno. And then they go back and match all the other ports to that particular one that's giving them the most horsepower. Just another application, and that's why I'm showing this. Application. These guys are in Santa Ana, California. This is a mold, but the part size does not matter. It could be large or small. This happens to be one of the boss's sons years ago, 5 years ago. He has laser tracker here, a little reflector he's holding on to, and the screen here shows the part, the section, and the deviation from the CAD model. So that's a 1 thou and 8/10 within tolerance because the letters are green, showing that it's a good mold. That happens to be the belly section for a Airbus aircraft. So size does not matter. So what was I going to do next year? Yes, I was going to, let me get this figured out here. I'm going to run a quick video, guys. That's going to kind of give you a quick snapshot on the Haas Formula One team. I'm hoping you can hear the audio on this thing. No audio. Not sure why that is. Let me restart it. See if we can close this stuff down. And it's right off the website. You go to the website, go to videos, provides the link, it shoots you over to the YouTube page. And there's, oh, by the way, there's 35 or 40 videos here that everybody's welcome to use, reuse, show, demonstrate to the classes, to students, to anybody. And there's some self-help stuff there as well, Frank. So your customer that has some questions on these demonstrations on how things operate, it's all there. Just another tool we have in the toolbox for everybody. I don't know why the video's not popping up sound-wise. Must be something holding it up. But as we walk through here, can you guys hear me okay?
Yes.
Yes.
Okay, so the Haas Formula One team out there, and I think in South Carolina, they did a shootout. They called in all the major software CMM competitors around the world and have them come in and show them the product. And right here, they're showing where some of their other shops are, Ferrari, and then they've got another shop in England. And the assembly plant is there in South Carolina. And they called up everybody, and Verisurf was one of the people that showed up. God bless Gene Haas. That man is unbelievable. Everything he's done for the industry as well as education. I think it's really cool that he's into racing. If I had his plant and that kind of money, I'd be right in there with him. Even though it cost him $250 to $300 million a year, I think it's awesome. So we went in and did a shootout, and they have a number of criteria that they wanted the competitors to meet before they purchased. And so as part of the shootout, we went in and demonstrated a number of the things that we can do per their requirements. And if the audio was running here, they'd discuss a little bit further, but you could see he's reaching into the machine, measuring the part before you take it out of the vise. And that's critical. And a lot of this is audio. So as the guy's measuring along, he can be listening to hear what's happening, if it's a good point, if it's a bad point, if he's measuring, if he's not measuring. That's a particular arm there that has a laser scanner on it. So he probably has it set up to plus or minus 5/1000ths of an inch, plus or minus 2/1000ths, whatever it is set up. So here's the requirements that the organization put on everybody. CAD-based, model-based. CAD is called a model. Comparable with all CMMs, which we do. We could import and export all CAD files and models. We work with all CAD files, PDF, annotated, drawings, comparative parts, and edit and add all of those things. Because as you know or might not know, Verisurf rides on top of the Mastercam design platform. And we put our metrology component on top of that. Mastercam is a strategic partner and has been since 1996. And so we have all those things built in with the support of Mastercam, which gives us a phenomenal product. And as Frank, you know, the Mastercam is continuing to grow. I think they're over 220 employees now. And they're by far and wide the largest CAM software program globally by a factor of at least 2. There's the digital trail right there. I'm going to just back that up a little bit, see if I can back it up just a touch. So here's the digital thread, reverse engineering, throw it into CAD, CAM, and then inspect it. That's the digital thread, and it could loop back around. So now he's using the touch probe, going in and measuring those parts. And with a touch probe, you can get much more accurately than a laser scanner. But the laser scanner is nice. You can sweep the things through quickly and just determine if you're in or out of tolerance. These are all the devices that we run at the moment. For educators, it's the scan. It's just the arms themselves. We have those little handheld scanners. We interface with all CMMs and the old ones as well. We've retrofit quite a few old ones. Preferably, they've already been upgraded with a Renishaw controller. So here's the guy there at Haas. They're measuring a wing section and comparing it to the CAD file. So we're measuring the real part and comparing it to the CAD file in real time. And that gives us what's called the deviation, or the delta between actual and virtual. And that's what's so innovative about Verisurf, and we've done it since the very beginning, and we've been the leader in model-based definition, where we're using a CAD model to define the tolerance, which is an absolute. You cannot change that. So you're comparing the cut part, the subtracted part, the milled part against the CAD model in real time. And the same with a 3D printed part. You can do the same thing with that because a 3D printer needs a CAD file to run. Won't run without it. That's where reverse engineering comes in as well. Another aspect of it. So that's a nice endorsement from those guys. Okay, so that's that. Well, just a touch on what we're doing in the industrial world, and now jumping on to the Verisurf program itself. This is a general look at it. For the guys that you all that run Mastercam, it has you can see the similarities. And so I'm just gonna start my day. I'm gonna warm up the program. I'm gonna load my CAD model. I'm gonna grab a cup of coffee. And the way we get onto the part, any part, is the same way. We're under the measure tab, and as an educator, you get our full suite of modules, which is a perk in itself. It's over a $20,000 perk. So you get all of these things as an educator. Normally you have to buy them separately. So when we import a CAD model, we import all the FTA, all the full text annotation. Everything comes in the CAD model, we bring it all in, which means all the tolerance and data is what we want. And that's how we can compare things. And so the way we transform or translate onto the part is using the mouse. You see we're up here, we're in mouse mode. And I'm using the left click on the mouse on the CAD model to identify the X, the Y, and the Z axis. And then I come over here on the left side where it says run auto align. That's on the left side over here. And I'm going to highlight that again. Left click on that once. And this is where the mouse becomes your measuring probe or your arm. You can see that little red dot underneath the X there. I've got the audio turned off. I don't know why I've lost audio, but I have. You guys still with me?
I'm here.
Okay. So we've done a transformation, and we've taken the opportunity to make sure that it's a good transformation on all axes, and I'm going to accept that. So now we're on the CAD model itself. My machine's running a little bit slow, but that's all right. So where my cursor is where the probe is. There's a little red dot that shows up once in a while. And just imagine the probe coming up and touching your part at the same time. And those numbers at the bottom are the deviation. And they go from green is good, and then it goes blue and dark and white, and oh my God, you're in trouble. So I'm just gonna give a quick picture again. Imagine measuring the part with an actual arm, but right now we're using the mouse to measure the part. I haven't clicked on anything yet. I'm just running my probe around the part. So if you're an instructor and a student puts a part in front of you, you can simply translate onto the part very quickly, run your probe around the part and see if there's any bad spots by seeing if the numbers stay green or go to blue or white. Now I did mention as part of this course title, I would quickly show all of the parts. These are just a quick snapshot of all the machines that we interface with. These are just some of the arms and the 3-axis CMMs. We're over 300 devices right now that we directly interface to. We can run a Haas CNC if we wanted to. Matter of fact, Xander approved that some time ago. And hey, Martin, Xander is back with us.
Oh, I didn't know. You never know where Xander's going.
He was with Autodesk and they cut him, and he came right back down here and we gave him a job. Matter of fact, he's got my office. That's why I'm permanently out of headquarters. We ran out of space and they gave him my office.
Well, tell him I said hi.
I will do that. Matter of fact, I showed him an old picture of him hooking up to a Haas machine, and with Verisurf, you can run a Haas machine. And we're going to be expanding the on-machine inspection here probably next year, because Boeing says you can cut a part on the same machine that you inspect a part, but it has to be a separate software program, and then that validates.
Okay.
You can't inspect the part with the same software that you cut the part, because then you won't know.
Nope.
So we've got the part. I'm going to turn the inspector back on, and I'm running my probe around. And if I'm off the part and it goes blue, I'll highlight that. If my audio is working, I'm not sure how it got shut off here. You would hear a Homer Simpson make a noise instead of a measurement point. It highlights the surface it's against. And those are actual measurements. So the bottom of this part is what a lot of the educators in their world live in, is these basic geometric functions. And so what we're going to do here is what I always like to do first is put a plane on top of the part. So I click on plane, move my left click. I'm putting a plane on top of this part. I'm going to say okay. And because I just reloaded a part earlier, it's retaining that same name. So I'm going to change the name of that son of a gun. Let's see. Here it is. Right. So now we got a plane on top of this part. We can turn it on or off. And I'm going to measure the inside of this hole or slot. And so I'm going to come in here and say circle. I'm going to say circle 1. Measure 3 points. I'm going to go to plane 1. It's going to be an inside diameter. And so what it's going to do is no matter where I put the probe inside that wall, it's going to bring the measured value up to the top plane. So it's a bold red line that goes around there now. Now we can do the same thing on the inside of that plug, but I can say, give me the outside diameter. I wouldn't need to roll this stuff around. Well, I messed up. You can see that. So we'll just go here to remove 3. Take circle 3 out. Looks like circle 2 was a problem, so I'm going to take that out. And do another circle, outside diameter. And it's going to measure 3 points. 3 points makes a perfect circle. So for demonstration purposes, that's fine. So that put a circle on top of there as well. It automatically created a center point as a for instance, and we can add a point as a center point. So you got lots of functionality here. How are we doing time-wise? We still got about 10 minutes. I can construct a center point as a for instance, and that creates a center point there, right here. And so from there, as a for instance, We can go ahead and make cylinders. We can measure circles. We can measure this bolt hole pattern. We can measure the arc between those. And if we wanted to double check anything, we can come back here to our levels manager and we can overlay the blueprint on it as a for instance. And we could see some of the things we want to do. 45 degrees between circles. This plug is supposed to be a 1 inch, 2 inch. So you've got that ability. It's extremely powerful, but extremely easy to use. So we've measured those diameters. Another thing that say they like to do on the NIMS parts or some of the basic parts that the instructors like to use is measure a slot. So if we want to measure the depth of this slot, what I would do is put a plane on here. And then say, okay. And the plane, we can measure plane 1, plane 2, and down at the bottom here, lower left, that gives us the distance as the crow flies from one plane to the next. So we know that the depth of that slot is 375. Now, because we're working in a virtual world, it's almost a perfect number, where in reality it would be plus or minus 2, 3, 4, 5 thousandths of an inch, something like that. Okay. And we could also, if we wanted to, we could run a quick report on that. These are highlighted and I can come over here to Report Manager. I could highlight these two guys. These are the Report Manager. And give me the distance here. I'm going to add that. And then report on it. And of course, when you report, you can export it, save it, do whatever you want with it. You can change the header, which student's working on it, what's the name of the part, etc. And then you can report on it. So the report manager is very easy to use and follow. Where to go? I've got too many things open and happening here. Let's see, I lost it somewhere. Well, lost it somewhere. Probably killed it and ran out of memory. I'm not
to save it in a location, or how do you know where it's supposed to go?
Well, it wasn't supposed to disappear on us, Frank, but when you save it, you've got all those choices of a PDF.
Right. But what about location? I didn't see a location like where you named it, but it looks like you had some ransomware thing pop up too when it happened in the bottom right corner. Like you're waiting for you to click it to bypass it or something.
You've got your choice where you want the file to be saved and how you want it to be saved or exported. I'm just going to restart it again. I think it decided that it didn't like enough memory. I have too many things going on today. Bouncing around with the Zoom stuff. It's not real happy with Zoom. I also lost the audio some time ago, or the sound effects. Not sure why that is, but it is. First time running a Zoom meeting like this. Usually we're on GoToMeeting or one of the others.
One of the things I did not check in the Zoom settings was live video. I thought I had that on my settings so that when I'm, teaching, I can get video from, YouTube or whatever, but I'm not sure if we lost that somehow when we set this up. I apologize if it wasn't working as well as it could have.
Well, that's all right. Just reload the part. Do a quick transformation, get back on the part. Yeah, it's running really slow. Something's holding up somewhere. Too many things run at once. So I'm just going to do the XYZ transformation again. 3 points on or 4 points on Z, 2 on Y, 1 on X. Runs a transformation. We're back on the part. So if we just wanted to put some points on there, or if we want to do continuous, we forgot to cover that. We come down here and select continuous, set the filter. I'm going to open up the filter up and say, and this is really great for scanning when you have a probe. I'm going to take a point every 100 thousandths. Now I'm just going to hold my trigger down, and this thing is collecting that data. You can see the points in the upper left-hand corner running up every 100 thousandths or so, as long as I don't run out of memory or my graphics card decides it can't handle the load. So that's great for reverse engineering as well. I'm going to stop it there at 1,200 points, say good. I go to my analysis. This is another tool in the toolbox. And I'm going to turn off my deviations. And I'm going to make it 3D spheres. I'm going to come back up here to my tolerance window. And if we had more errors into the measuring sequence or the part, it would show it more as a color topo map. But right now it's measuring perfect. Too bad. It will, those colors will change depending on the tolerance band of the part. Let's see. All right. So that's another thing we can do along those lines to, as another tool in the toolbox. We can print that out, we can screen save it. There's lots of things we could do there. See, here's your report. Manager, Frank. And here's your choices of export features or save features. Let's see what happens to us this time. Oh, it walked off screen. Here it is. Now, once it's at this point here, Frank, your question was, this is how you'd save it?
Okay, got it.
Standard setup. Cut that. It actually walked off screen. All right, and then we close it.
Could have been behind it. You didn't even know it.
Could have been, as you can see. No, not there. Good choice, though. Good call. So one of the things we can do here is flip this thing around. Turn off the deviations. We could also do standard master cam stuff. Things are running really slow. There we go. So we can put a plane on here. Put a plane on the top. Put a plane on the bottom, or in this case, the top. Oh, you know what? I'm still on continuous. So that's an operator error. There we go. That will make a lot more sense. So I'm going to delete that. And we'll put a plane on the top of this part. It's all locked up. This does not like zoom. Two planes on top of each other. Needless to say, we can amplify my point, and that is that highlight both of those, and it gives us the distance down the lower left. In this case, it's 0 because they're both on top of each other. So we have all these geometric functions available. You get the reverse module, you get MBD, you get the automated module for generating toolpath for CMMs, for automated CMMs, which is becoming more of a feature for robotic lights out manufacturing, where the robot takes the part out of the milling machine and drops it right into the robotic cell. It takes it off the machine, puts it in the CMM, measures the whole thing, and determines if it's good or bad or not. Okay. This thing is not happy with all the stuff I got going on. Well, one last thing I was gonna run through here with everybody, and that is, it doesn't matter what the part is. This just happens to be one of the sample parts it comes with. As far as training goes. So complexity is not an issue anymore when it comes to part inspection. This is just a basic composite part, and it's probably closer to what a lot of the instructors are using. And they could also annotate their part with the new features that we have where you can build all of this in. This was a layup between a gap and flush, where you have a aircraft door for a wheel well that closes. You want to make sure that those things close up tight and they're level for the stealth aircraft. This is, again, another highly complex part. Verisurf makes it easy to do. It's just going through the motions. And you could also set up a measurement sequence. So if you're an instructor with student parts, you can set it up so you measure each part the same way every time, and it makes it very fast and easy. You just follow the bouncing ball, and it'll walk you through where to inspect each part. And you can also automatically generate a report depending on how you've got the file set up.
So Ray, I have a question. Now that you're showing parts and you've shown drawings in the past, we have G, D, and T there with your feature control frames. Now that's a one that is an important idea for teaching. How can your software and these tools help with not only creating those or measuring for them, but also teaching the idea of concentricity, location, and so forth?
Well, a good way to go is right here on the left-hand side here, second from the left on the upper icon bar.
Mm-hmm.
Measure reference guide. This is available to everybody, and it comes in the demo software as well. I mean, the full Verisurf Learning Edition software. I think it's about 105 pages, and it walks you through the whole measure module, and you could actually use the table of contents as curriculum development, or just a good sequencing to follow if you're going to teach the course or walk people through different aspects of the course.
Okay.
You're welcome to use it, reproduce it, teach from it. We're here to help you make your lives better and your students smarter, and the employers happier.
Okay. Thank you.
Yeah, so to address your point, I would direct persons or people to the reference guide. And from there, they can speak to it as we would speak to it. And then it's, as your one customer, Frank, you can download this thing. I'd print it out if I was them, so you have it to flip through while you're looking through things. And when you're running the online video training and you're running the software program side by side, it becomes interactive at the same time. Plus, you can refer back to the reference guide anytime. Anytime. And one other thing I do have that we can provide is, we call it tips and tricks. Let's see if I can find it. Oh, I'm out of memory. Just about, no, it's going to give me some. Just stand by a second here and I'm going to pull up those tips and tricks. We got a few minutes left here.
And this session will segue into the Immerse to Learn session, which is going to be at 1 o'clock. So for anybody interested, we've talked about how Immerse to Learn, the online Total Machinist curriculum, does have the opportunity to embed the Verisurf curriculum in as well. So Chris will be showing that in the next session at 1 o'clock.
Right, so this is another document I'm happy to forward to you, Frank, and these are active. That will take you right to these different things. Reference guides for version 2020. It has all the reference guides for all the modules. It has a book of technical tips. So there's system, there's general information, alignments, and measure. And happy to provide this to your customer with this as well. And it's nice as it kind of breaks it down into different areas that you want to quickly check and remember how to do something. As for instance, inspecting a hole pattern, best fit a hole pattern. Matter of fact, the whole subject of best fit is one in itself, and sometimes people have a hard time getting their arms around it. Yeah. So best fitting is often used in industry to make sure a part is good when the initial sequence says that it's not. So by best fitting allows you to move the part around inside the CAD model to get all of your tolerances within an acceptable tolerance. We can cover more of that later. So this is a nice little tool for your toolbox to use, and you guys are welcome to it. I'm happy to send it to you as well. Another thing about the software that's coming up that's available for new customers or old customers is the dongle, the HASP dongle is no longer required. Frank, you're probably familiar with that with Mastercam.
Yeah, the only problem with that is if they have multiple computers, they bring them from one computer to another, then you got to export or you got to transfer the license or something. It's kind of like SolidWorks,
Okay,
So I like the key in some, especially for an instructor, that has maybe a computer at the school, then a computer at home, and another one, at the cabin or whatever. So that this makes it easier to be mobile versus having to buy multiple, instructor seats.
Yep, and they can't be lost. And it's an easy upgrade or to renew the maintenance on it as well.
Got it.
But I haven't heard that one about having to switch between computers and if it's a trouble or not. I figured if it's on the server, it wouldn't be an issue.
But just the server from the school has got to be able to see the license from the laptop,
Yes.
all their firewalls and all that. So.
Right. Yeah. So there's some issues there.
Like if you're traveling in a hotel or an airport or something, the
Right.
dock is really nice.
That too. I guess you'd have to access the school server if that's permittable.
Which you also got to access Wi-Fi. If you're in the middle of the wilderness somewhere, you want to go do some programming or something, you got to be connected, right?
Yeah, but has that ever been an issue? I mean, do these guys practice?
Well, they just started doing it. So.
Oh, good point. Yes, good point. I forgot. Yes. Right. They want to go sit on a park bench somewhere in the shade.
It has been an issue with SolidWorks because SolidWorks, you can check out a license. It's kind of a headache, that's all. But I like that they've gone away from the key, but some teachers are like, well, I want the key still. Like Mastercam allows you to choose if you want the key or not.
It's the same with us because our keys ultimately come from Mastercam. So
Correct.
it's the client's choice on how they want to proceed on that.
Okay, well, any further questions? Ray's going to be here on this channel all week.